Bismillahirrahmanirrahim. Assalamualaikum and very good evening. Welcome to the class again. Okay, in this video, I will discuss the tutorial 2.1, which is the example of ultimate moment resistance for rectangular beam at mid-span, which is the singly reinforced. Okay, we can open the module, page number 30, okay, 31 until 32, okay. Tutorial 2.1, okay, the question is determine the ultimate moment of resistance for the rectangular cross sections of a beam in figure 2.1 below, which is located near the midspan. So, if you find this type of questions, you must be able to detect the key point. What is the key point here? I mean the keyword. Okay, near midspan first. Okay, when is come to near midspan, what is the first thing that come to your mind? Yes, compression. Where is the compression? Top. Okay, compression is at the top here. This is the compression. So the tension? Yes, bottom. So that's why in this figure, I mark that the tension reinforcement with this line. Okay, I mean black line, and then with a darker field. And then at the top, this is only we name it as a hanger bar. This is also bar. We must provide bar at least 2 or 3, maybe depend on the percentage later. We will learn later, but this is also function as hanger bar. Okay, and then another key point here. Another key point. One more key point. Rectangular. Yes, rectangular means rectangular. We don't have to consider for flange. Okay. So, and another one is the moment of resistance. Means for this case, the area of steel provided is given by this one. This is as provided for number, okay, for H20. 20 means the, yes, this is the diameter of the steel bar. H is the type of steel bar, okay, high yield steel, where the FYK is equal to 500 Newton per millimeter square. Okay, this one. Okay, and then 4 means the, yes, how many bars? The number. So we can calculate 1, 2, 3, 4. Okay, clear? Okay, so this is the BWH and so on. Okay, the concrete class. Okay, if the concrete class is given by this type of writing, so you must be able to determine what is the value of FCK. What is the value of FCK? Yes, FCK is equal to 30 Newton per millimeter square. Okay, next. Okay, so you must recall back your knowledge here. So the tension occurred at the bottom. Okay. Okay, so we provide the tension reinforcement at the bottom. So this one also you can recall back, okay, from our previous video. So here, okay, comes to the solutions. Okay, first we must to determine the value of D. D is the effective depth. So we can refer to page number 30 in the module. So in case of near the midspan, okay, near the midspan, the effective depth D is measured from the top of the beam until to the center of the tension reinforcement. This is the definition of D. So, and this is your nominal cover, and this is your link, okay, for shear reinforcement, and this is the diameter of tension bar divided by 2, okay, which is half. Okay, so this is the equations. D is equal to H minus C nominal minus diameter of link divided by 2. So what is the, can you help me to solve this problem? Okay, 550 H 550 minus nominal cover, what is the value? Okay, 30, the link 8, okay. Tension reinforcement 20 divided by 2. So what is the answer? 502 mm. Okay, so this is 502 mm. So you refer page 18 in the module for the stress block diagram. So you must be able to sketch just a simple sketch like this one. this is your cross section of the beam. Okay, it must contain the BW, and then complete with the H, and then okay, maybe I can use a different color. Okay, this is your number of steel bar, 4 numbers at the bottom. It's okay, you can neglect the link. Okay, you don't have to waste your time. So for the stress block, so you just simply write down the final result. Okay, the final result is like this one. Okay, this is your stress block. Okay, and then this is your compression. Okay, due to compression, so I want to use a different color. Okay, sorry, I want to use different color. So this is your FCC, and then how about another one at the bottom? It shall be F what? Yes, FST. Okay, so it must be here, coincide to the line of the central of steel reinforcement. Okay, and then since this is your very simple. Okay, this is the neutral axis, and then here is your this is your S, which is equal to 0.8x. Okay, so this is your D, and this is your Z. Okay, Z is here. This is your Z. Z is equal to V minus 0.4x. And then here is your BW. Okay, clear? Okay, so I proceed. Okay, for equilibrium, the FCC, okay, FCC here, this one, okay, the FCC must equal to FST. So as we discussed before, the tension, the force is equal to stress multiplied by the area. So the stress in concrete equal to 0.567 FCK. This is the stress in concrete, and then the area will be BW multiplied by 0.8x. Okay, and then stress in steel is equal to 0.87 FYK, and then multiply by the AS provided directly. Okay. Okay, so can you help me to solve this equation? 0.567 times, what is the value of FCK? 30, okay, 30. Okay, so the value of BW, 250, and times 0.8x. Okay, and then 0.87 FYK is equal to 500, and then our S provided is equal to 1257. So can you solve the value of X for me? Okay, anybody? Okay, 160.7 mm. Okay, 1 decimal places is enough. Okay, 160.7 mm. Okay, you got this answer? Okay, and then to determine the ultimate moment resistance, so the FST here, moment about central of the concrete, okay, compressed concrete. So this is our Z. So the FST, okay, the forces times the Z is equal to moment. Okay, so FST is equal to area of this one. FST is equal to 0.87 FYK times AS provided. Okay, this is our FST, and then the Z is equal to D minus 0.4x. So 0.87 times 500 times 1257. Okay, and then the D is 502 minus 0.4 times 106.7. Always divide by 1 million. Okay, in order to get back the unit of kilonewton meter. So you please don't forget to divide by my 1 million. Okay, use your calculator. Later you divide by 1 million. Okay, what is the answer here? Anybody can give me the answer? Two three nine point. Okay, 239.3 unit is kilonewton meter. So this is the capacity of the beam. Means this cross sections is able to resist up to 239.3 kilonewton meter of design moment. Okay, if the design moment is larger than this one, so it will fail. Okay, clear? Okay, thank you very much for your attentions. Okay, congratulations. Now you can try and enjoy exercise A1 to A4 from the module, which is in page 33. Okay, as your exercise, as a homework. Make it repeatedly. Okay, thank you very much for watching. See you in next video. Assalamualaikum and bye-bye.